Hello friends. This is the first video of a course that I have prepared on Arduino. If you want to get started in the world of electronics, microprocessors and everything related to the maker world, this course will help you. In this first video we are going to see what Arduino is, the different Arduino models that you can find, the software tools that you will need, and finally we will see the basic structure of an Arduino program through a simple example, which we will transfer and execute on our board Arduino. My name is Johanna and I hope this video is of interest to you. In that case, don't forget to drop a like, subscribe to this channel and activate the notification bell. Arduino is an open hardware and software development platform that allows you to carry out electronics and automation projects in an easy, fast and fun way. With Arduino you can control motors, detect signals, activate devices, measure physical parameters with sensors, control lights, and much more. If you visit the web www.arduino.cc, you will see that there are various versions of Arduino boards. Among the basic boards you can find the Arduino Uno, Nano, Leonardo or Micro models. Without a doubt, in this group the most used board is the Arduino Uno model. Below, we can see boards with improved features, such as the Arduino Zero, that offers more CPU and internal memory capacity, or the Arduino Mega, that offers up to 54 digital inputs or outputs. Finally, we see a set of Arduino boards focused on applications of the Internet of Things, the so-called IoT. In this group, the MKR family stands out for its different form factor, with a smaller size, offering for example, integrated modules for Wi-Fi and Bluetooth, so these Arduino boards are very suitable for the maker world. For this course, I have chosen the Arduino MKR 1010 board that will allow us to develop both basic and advanced projects, especially IoT projects. I have chosen this Arduino model since it incorporates many interesting features, such as a low-consumption microcontroller, with 32-bit computing power, built-in Wi-Fi and Bluetooth connectivity, without the need for additional shields, a recharging circuit for an external lithium polymer battery so that the board can work without mains power, an output pin to generate an analog signal, 13 pins to generate PWM signals, and many more features. Now that we have chosen our Arduino board, we are going to talk about the tools we need for programming the microcontroller. As I have already mentioned, an Arduino board has an integrated circuit called a microprocessor, which is in charge of executing a program, which is nothing more than a sequence of commands or instructions, which are expressed in what we call a programming language. There are different programming languages like Python, C, Java, and many more. For our Arduino board we will use the programming language called Arduino language. As you can see, its creators did not complicate their lives when choosing the name of the programming language. In programming, the most basic way to write a program is to use a plain text editor like Atom, but to facilitate this process, Arduino provides a programming tool called IDE, which stands for Integrated Development Environment and that we can download from the Arduino website. This is the Arduino web page, and if we click on Software, a new menu will appear where we can see the links to download the Arduino IDE, both for Windows, Linux, and Mac. The easiest thing is to directly download the executable installer that will completely install the software. After downloading and installing the IDE, that is the development environment, we can connect the Arduino board to the PC and run the software. In the Arduino environment, a program is called Sketch and it will contain the instructions that the microprocessor must execute. The structure of a program for Arduino is basically made up of two blocks. The first block is defined by the setup function, and the second by the loop function. We can identify both words, setup and loop, as functions because behind them appear the opening and closing parentheses. In a programming language, a function is an element that performs a specific task. For example, a function can add two numbers and return the result. In this case we see that the setup function begins with the indication, void, which indicates that this function does not return or generate any information after being executed. The instructions to be executed are placed between the left brace and right brace characters. In this case we see that within the setup function we have a line of text that begins with 2 slashes, which is the way Arduino uses to add comments. The comments serve the programmer to better explain or understand the program, although the Arduino ignores these comments during the execution of the program. The purpose of the setup function is to include instructions that are only executed once, for example, after the program code is loaded onto the Arduino board. The second block of an Arduino program is made up of the loop function. The void indication is also included, so this function will not return any information either. The instructions that make up this function are also written between the left brace and right brace characters. As we can see, in this case the loop function only contains a comment made up of a sentence that is preceded by the 2 slashes. In the case of the loop function, the instructions between the left brace and right brace characters will repeat from beginning to end and so on in an endless loop. Once we understand the operation of an Arduino program or sketch, we can see some examples of programs. The IDE includes several sample projects that can be used for initial learning. In this case we go to File, Examples, and we can see different groups of examples. One of the classic examples is Blink, that will make a LED blink. In the first part of this example, we see that there is a comment that uses several lines. To avoid having to insert the 2 slashes at the beginning of each of the lines, we can start the paragraph with the slash followed by the asterisk and end the paragraph with the asterisk followed by the slash. In this way Arduino will treat the entire paragraph of text as a comment. It is typical for a program to include a comment at the beginning that explains what the program does. In this case, as I already have commented, a LED included in the card itself, called built-in LED, will be controlled. If we move forward in the program, we will see the setup block that includes a new comment where it is explained that the following command is used to initialize the LED built-in pin as an output pin. In this way it will be possible to activate that output so that it provides voltage to the LED and it lights up. As you can imagine, if a pin can be configured as an output, it will also be possible to configure it as an input, in order to detect an external signal, for example. As we have commented, the setup block is executed only once. In this way, after initializing the built-in LED pin as an output pin, the microprocessor reaches the loop block. Inside the loop function we see that the first action that must be executed is the command digital write, which will put the built-in LED pin to a high logical level. In the case of the Arduino Uno it will be 5 volts while in the MKR it will be 3.3 volts. This voltage will cause the LED to turn on immediately. After that, the program will continue to the next instruction, which in this case is the delay instruction, which makes the microprocessor wait for the time indicated within the delay command itself, in this case 1000 milliseconds, that is, 1 second. During this time the LED will remain on. Once the delay instruction has been completely executed, the microprocessor executes the following instruction, which is again the digital write instruction, but in this case it uses a low parameter, in order to change the logic level of the signal applied to the built-in LED, from high to low, that is, to 0 volts. In this way, the LED will turn off as it is not anymore under voltage. Finally, the last instruction of the loop block will be executed, which is another delay instruction, which makes the microprocessor wait 1 second again before moving on to the next instruction. But since we are in the loop block, and this was the last instruction, then what happens is that we jump back to the beginning of the loop block and the whole process is repeated. As you can imagine, what this basic program does is continuously turn the LED on and off with a frequency of 1 second. Now is the time to take our Arduino board, connect it to the PC through the micro USB connector on the board and transfer the program from the PC to the Arduino memory. In the IDE we go to the Tools menu, and we see the option board, and we verify that our board model has been selected. However, in the list of boards does not appear the board MKR WiFi 1010. We can add it manually, but in our case the IDE itself has detected the card when connecting it to the USB port and offers us to add it automatically. We accept and the IDE will begin to install all the necessary elements required to use our board. Once we have installed the board driver, we can return to the board menu to select it, since now it should appear in the list of boards available. If the IDE does not offer us the possibility of installing our board automatically, then we will have to do it manually. To do this, we go to Tools, select the Board option and then Boards Manager. In the search window we enter the word SAMD, associated with the type of microcontroller on the board MKR, and our board should appear. In my case, as I have installed it automatically, the option to install the board is disabled and only the option to remove it appears. Once we have the board installed, the next step is to select the appropriate communication port so that the PC and the Arduino board can talk to each other. To do this, we go back to the Tools menu and select Port. If we are not sure what port to select, we can go to the Device Manager and in the Port section see which COM port is created when connecting the card to the USB port of the PC. In my case, it is the COM port number 6. We return to the Tools menu, then Port, and now we select the appropriate port. In this case COM6. Now we have everything ready to transfer the program. We make sure that we have our Blink program open on the IDE working area and we simply press the Upload button that is in the upper left part of the screen, which has a small arrow pointing to the right. At that moment the IDE will begin to transfer the program to our board, and at the bottom of the screen we will see information about the memory required by our program on the board, as well as the total memory available. If all goes well, a message will appear indicating that the upload process has finished correctly. At that moment our Arduino board will execute the sketch, first the setup function, only once, and then the loop function, repeatedly. And as we can see, indeed the onboard LED begins to blink with an apparent frequency of 1 second, which is an indication that the program is executing as expected. And so we have reached the end of this first course about Arduino. In short, we have seen what Arduino is, the most common types of boards. I have presented you MKR 1010 Wi-Fi board that will serve as the basis for most of the projects in this course. We also have downloaded and installed the IDE, that is the Arduino development environment. We have seen the basic structure of an Arduino program, called Sketch, and we have loaded and run our first program on the Arduino board. I hope you have found it interesting. If that is the case, don't forget to drop a like, so that I know that you liked it. In future videos we will go deeper into the use of the Arduino platform, developing new projects and discovering new features. Therefore, if you don't want to miss them, don't forget to subscribe to this channel and activate the notification bell. See you in a next video. Bye.